We're going to talk about the finance app on the calculator. And the reason, yes, possibly. Okay, guys, what this app does is it helps with problems that involve a payment of some kind. Because this is the formula right up here, I don't know if you can see, that would be used to find the future value of what's called an annuity account. In other words, like if you're going to put $100 away for college, if your parents were going to put $100 away for college for you from the time you're born until the time you leave for college, every month they put $100 in, okay? This would help calculate how much they were going to have. Or if I was going to put away $200 a month towards retirement every month. The formula is complicated to figure out how much you're going to have at some future time because some of the money is going to be been sitting in there much longer than other money, right? If you're continually adding a payment to it. Does that make sense? So this is the formula. It's very complicated. There used to be a pre-calc teacher who made them do this by hand for a whole day before she showed them the app, okay? I'm not going to go there. We're going to use the technology, okay? As you can imagine, if you had to do this by hand, you could still use a calculator, but you would need about a bazillion pair of parentheses, right? To get that in there, right? The other formula we're going to talk about in a few minutes is this one, which finds the payment, okay? So if you borrow money for a car or a house, this will calculate how big your payment will be. Also, a bunch of parentheses would be needed, right? So these are able to be solved using the finance app on your calculator. And the best news is that it will solve for any of the missing pieces, okay? Now, it's called the time value of money solver is where they get this TVM that we're going to see in a minute. All right, so take your calculator. Any Texas Instruments graphing calculator, no matter how old, will have this app. The app key is on the left side of your calculator, but next to math, it says apps. Everybody find it? The very first one should be finance, and you may have others, but everybody should have finance. Even the oldest versions of the Texas Instruments graphing calculators have finance. Everybody have finance? That's okay. It'll still do finance. Yeah, if you have, guys, if the calculator's in press to test mode, it'll still do the finance app. So then you hit enter, and the first thing at the top says TVM solver. Everybody do that? And then if you hit enter again, you should have a screen that says N, I%, PV, PMT, FV, etc. We good? All right. You are going to need for the quiz to know what these things stand for. I'm not going to quiz you on it, but you can't come up and ask me, I don't remember what goes here or what this stands for, okay? You need to have done the assignment, practiced, do it in class, do the worksheet so that you know how to use this. The N, this is on your notes. The N stands for the number of payment periods. Now, if you're going to make quarterly payments into something for 15 years, you would do 4 times 15. The nice thing about this, is everybody listening? When you go into this spot, it will let you in that spot type 4 times 15 and it'll calculate for you. I know you guys could do 4 times 15, but if it was 55 years of monthly payments, 55 times 12 is a little painful to do, or you'd have to get out and go back to the home screen. You can just type it there as a multiplication problem, it'll do it. You understand what I'm saying? Then if you go down, the next one is I for interest rate as a percent. You do not have to move the decimal this time. Okay? It says as a percent. PV stands for present value. If you're borrowing money for a loan, you're going to put the amount you borrowed there. If you want to know, you've been putting payments in and you want to know what it's worth now, that's where you're going to put your cursor to solve for that. PMT is the amount of payment. Okay, we can solve for that, or we can put that amount in. FV is future value. Everybody listening? Because future value, if you are borrowing money for a house or a car, your future value means at the end of the loan. What do you want to remain at the end of the loan? 0. So if it is a loan and you're paying it off, you want the future value to be 0. If it's a retirement account and you're making payments into it, the future value is what you want to calculate, right? You want that to be $1 million or whatever it is. P per Y and C per Y are payments per year and compoundings per year. Those generally, for all the questions we're going to do, those need to be the same. The P per Y and C per Y will just stay the same, okay? Meaning the same as each other. If it's monthly, they'll both be 12. If it's quarterly, they both be 4, etc. All right? The bottom thing, it says end and begin. Is your payment at the end of the month or the beginning of the month? The default is end of the month, and that's where we're all going to leave it. Does everybody say end at the bottom? Okay. We're just going to leave it on end of the month. All right. So here's our first example. I would suggest you keep track of what you type in so that when you go back and you don't remember what you did to get that answer, you can write it down. And I would also suggest that on a test or quiz, you would write down these things, what you typed in, because if you get a wrong answer, then I can say, well, it wasn't a conceptual error. What they wrote down was right. They must have just typed something in wrong. Okay. So an investor pays $600 quarterly into an annuity. This means that every 3 months, they're putting $600 away into an account and leaving it there. The annuity is earning 7.24% annual interest. Okay, annual interest doesn't necessarily mean it's compounded once a year. That's just the rate for the whole year. Because this says quarterly, we're going to do quarterly for the interest as well. What will the value be after 15 years? Now, they will have been making payments every quarter for 15 years. But the first payment they put in until the last, there was interest accruing as well. All right, so N is number of payments. So how are we going to figure that out? Okay, 15 times 4, 4 times 15, it doesn't matter. You can just type a 60 if you want, but that's what's going to go there. The interest rate, we're going to put 7.24. Do not move the decimal over. The present value, we're going to start with nothing in the account, and we're going to make payments of $600. The future value is what we want to find, so we're eventually going to put our cursor in that spot and ask it to solve. Payments per year and compoundings per year, we're going to put 4 because it said quarterly. FV is where we're going to put our cursor and tell it to solve for that amount in a minute. All right, so turning the calculator, we're going to put 60 or 4 times 15, and you can literally type 4 times 15, and then when you arrow down, it'll put a 60 there. The I is 7.24. Present value 0. Payment $600. Future value is what we're going to try to find. You can leave an old number in there. You can put a 0. It doesn't matter. Eventually, we're going to solve for that. And then we're going to put 4 and 4 in P per Y and C per Y. We're going to go back and put our cursor on FV. Now, before we solve this, 2 things. When money comes into your account or goes out of your account, you understand that those have to have different signs, right? Like a positive and a negative, like a withdrawal and a deposit have to have a different sign, yes? So when we do this, we're going to get different signs, whether it's a future value or a payment in, because it's like, is the bank getting the money or giving you the money? It doesn't matter which sign it is. It's not negative money, so you're always going to answer as a positive, but the signs are going to be different. You'll see this in a second. I put in a positive $600 payment. So when it gives me back a future value on the account, it's going to be a negative. Because one way was me putting money in the bank, one is what it's going to come back out. I could change it. I could make my 600 negative, and I'll show you that in a second. All right, to solve. How many of you have seen this little green solve here down by this enter button and you thought, oh my God, if my calculator can solve for everything, why am I doing all this work? Well, this is the first time we actually get to use solve. You're going to put your cursor on future value, and then instead of second enter, you're going to push alpha enter, and it's going to solve for that amount. The future value of this account is $64,102.91. Did everybody get that? Now, it says it's negative because we put a payment in of positive. If we had said, if I go back up here in my payment, negative 600, then when I go down to future value and solve again, I get a positive. It doesn't matter which way you put it in. It doesn't matter to me. One is just you giving the bank the money, and the other way is them giving it back to you. Okay? Yeah, Andrea. It has to have a different sign in the program, because it has to, if I said, it's just like the idea of a deposit and a withdrawal. You can't make them both positive. Does that make sense? If you're balancing your bank account, right? A deposit and a withdrawal have to have different signs. The same thing, whether you're paying the bank or they're paying you, they're going to calculate with a different sign. Okay, but I don't want you to say, my annuity is worth negative $64,000. Okay. Questions? Everybody got that? We're good? All right. We're going to move down to this example. It says you're going to borrow $170,000 from the bank to purchase a home. The 30-year loan, we're going to borrow it for 30 years at an interest rate of 4.5%. We want to find the monthly payment and then the total that we have paid after 30 years. Back up a second. Can you go back to the home screen? So quit on your calculator. I want to talk just 1 second about this. How much money did we put in the bank? Once? 4 times a year. We put $600 in for 15 years, yes? That's $36,000. So out of our pocket came $36,000. The rest of that is interest. Okay? Do you understand? I just want you to see that this wasn't... Yeah. Okay? Yes, it's a higher interest rate than you'll probably get today at a secured rate. You could get an interest rate like that possibly if you invested in something risky. Okay, go back to this question. Where is $170,000 going to go? Any ideas? Yes, we are presently borrowing $170,000. You can put it in as positive or negative. It doesn't matter. Your payment is going to be the opposite sign. What else do we know? N is going to be just 30. We're going to make 30 payments. 30 times 12. It's 30 years of monthly payments. Okay? The interest rate is going to be 4.5. The payment is what we're trying to find, so that's what we're going to put our cursor. The future value. Yes, because you want to know at the end of 30 years that it's paid off. Okay, it's a monthly payment, so we're going to do 12 and 12. I don't think you'd want to pay once a year for 30 years. It says monthly payment amount. Do you see that now? Say that again. It doesn't. It compounds monthly. When you make a payment, they figure your interest off their payment. It doesn't say an annual interest rate just means averaged out over the year. It's still split into pieces. What was the interest, guys? 4.5? Okay. Okay, so when we get that all put in, we went to payment and we solved and got $861 and something. Anybody get that? $861.37. Real quick, if you borrow money from a bank, it used to be you got a little, like a checkbook that you tore a paper out and you sent it in with your payment, and it had all your account information on it and everything. And at the end of that booklet, it would say, for final payment, see the bank. Okay? That's because we just rounded. You see, we just rounded this. And so at the end, that last payment is going to be off by a few dollars or cents. Does that make sense? Okay. Now you don't get that little payment book. They don't bother because most everybody pays everything electronically. But that last payment, they will still tell you to call for the exact amount you owe on the last payment. All right. How are we going to figure out how much we actually paid on this loan? 861.37 times what? Yeah, 12 times 30 or 360. This question is on the test, and everybody, half the people in the class will say, I don't remember how to get that. But does it make sense to you when you really think about it? This is the payment you made 360 times, right? Okay, so when you paid that 360 times, it's a big amount. How much? How much? 310. Okay. Hey, and whatever change. I don't really care. Okay. So do you understand that you paid for almost twice the house? Yes? Because that's interest. But the bank gave you $170,000 and didn't get their money back for, I don't know, 20 years or something. Okay? Now, I will tell you that you always, and we can do this another time when we have more time, but you always want to make the biggest payment you can afford and take it out the shortest amount of time. Let me just show you this. If I changed, all I did was change it to a 25-year mortgage. Okay, think about this. 25 times 12, same everything else. The payment only goes up $80. Okay, and somebody do 945 times 25 times 12. 283,000 roughly. Okay, so by paying an extra $80 a month and borrowing it for 5 years less, I saved $27,000, almost $30,000 in interest. Okay, you pay a lot of the interest up front. It's fast. Anyway, it's all complicated. I'm just going to keep going. All right, guys, real quick, your assignment on this particular section, we're going to do more of this, but the book work is to do 1 through 9, odds, and 13, okay? 1, 3, and 5 are annuities. So this is your payment, and this is how often you're making it. Semi-annually means your payments per year are going to be 2, okay? And for 12 years, so N will be 12 times 2. Everybody okay with what we're doing on this section? Bi-monthly would be twice a month, so you'd have 24 payments, but you don't have to do the even ones anyway. Anybody need more time to write anything down? annuity means you're looking for a future value. And the fact that this first one says semi-annually means you're going to make P per Y and C per Y 2. And it says for 12 years, so you do 12 times 2. Okay, you can go, I think you'll be okay with the rest of it. Then you're going to do 7 and 9, which say find the monthly payment and, guys, 2 parts to this, the total paid for the loan. Everybody okay? Make sure you read that carefully. Number 13 is a really great application question. If you get stuck on parts, we can talk about this Thursday or Friday, okay? The second thing we want to talk about today is understanding when to actually use that app and when to use the formulas on your yellow sheet. Can everybody make sure they have the little yellow strip out? All right, the first question on 4B says find simple interest. Okay, that is a formula that's on your sheet. The formula is I equals PRT. Simple interest. Right, an example of when you would get, banks don't usually charge simple interest, okay? I borrowed my first $5,000 from my rich uncle to be able to put a down payment on a house because I didn't have enough for a down payment. He said, I'm just going to charge you simple interest. Pay me back in 3 years. So I didn't have to make payments. I just had to somehow save up enough money to pay him back in one lump sum, and he just charged simple interest. Okay, so this example says you're going to $4,000 at 6.2%. We do have to move it over. We're not using the app for 8 years. So our time is 8 years. Now, when we do this, I think it's 19 something, 19. Thank you. That's the interest only. Does that make sense, guys? That's the interest only. So it says find that and find the total value of the investment. Okay, this wasn't a loan, it was an investment. So this is the interest, but the total value would be the $4,000 we put in plus the interest. So we'd have $59.84. We don't normally have to do that when we do questions about compound interest like this next one. Okay? We normally don't add the interest in because the compound interest formula is future value equals present value times 1 plus 0.062 over 12. The 1 plus means 100% of your money plus interest. So we don't have to ever add the interest back in. Okay, what is the present value for this number 2? Same $4,000, right? But this time it's compounded monthly for 8 years. So are we going to have the same $59.84? More or less? It should be more. Okay, we're again not using the app. We're just using compound interest formula. You can cheat and use the app, but you have to trick the app into working. And I'm never sure I'm tricking it into working right. So the only way I would know would be to check with the compound interest formula on my calculator. And why would I bother, right? I got 65.60 and 18 cents. Did anyone else get that? Okay. Do you want me to show you what you would have to do if you were going to use the app for that question? Is you would have to say 12 times 8, 6.2%, present value $4,000. You'd have to say I'm going to make 0 payments, $0 payments, and then leave these 12 and 12. And then when you solved, you'd get 65.60 and 18 cents. But you're not really making $0 payments. You're like tricking it. Okay, so I would just use the compound interest formula. That's why you have the yellow strip. Make sense? The app or where are you at? Oh, you don't have the 1 plus? Oh, you're missing a parenthesis. You don't need a parenthesis here, but if you do put one here, then you need another parenthesis here. So I wouldn't use one in front because then you're gonna forget and mess it up behind. All right. The next question is a compounded continuously question. What does that mean we need? Yes, we need this PERT formula that's on your sheet. So we have 4,000 e to the 0.062 times 8. This should be a little bit more yet than what we just got. And again, there is a way to trick your calculator app into doing this, but I wouldn't suggest it. That's why you get the formula. Anybody 65, 68, 56? Yes? No? Okay. The trick is, guys, you could go down here and say compoundings per year instead of 12. You could say like 9999, meaning continuously. And then you'd get the 65, 68, 50 something, okay? But I wouldn't suggest it because you're not going to remember all those little tricks. All right, this next question, you also don't need the app for, though you can use the app. 5 years from now, you'd like to have $10,000. What is that? Future value, okay? To pay for a trip around the world. Your investment company says you should be able to make 5.5% compounded monthly. So at compound interest, you'd have 1 plus 0.055 over 12 to the power of what? How long till you want this money? 5 years. So you'd have 12 times 5 or power of 60 up there. It says, how much would you need to invest today? So we're going to put all of it in at once. So could we solve that real easily? What would we do? 10,000 divided by all that garbage, right? $10,000, make sure you get all your zeros in, divided by parenthesis 1 plus 0.055 divided by 12 to the power of 60. I got basically $7,600 plus some change. Okay. Again, you could do this on the calculator. You'd have to tell it you're making $0 payments. So you would do 5.5. Present value is what you're trying to find. Payment of 0. Future value $10,000. 12 and 12. And then you'd solve and you'd get the same thing, 7,650 cents. Okay. I would not use the calculator probably for that one. All right. This is a rate of return question, and I need you to have your little yellow strip because it's wrong on there. A rate of return question, I don't ever use the formula. It's probably why I typed it wrong on there. I pretend I'm going to put $1 in an account, and I'm going to leave it compounded quarterly. 1 plus 0.052 over 4. I'm going to leave it there 1 year. So 4 times 1 power, and then I'm going to take my $1 out. Anything I made is interest, yes? Okay. The other one says I'm going to do the same thing daily. 0.0512 over what? Daily, 365. I'm going to leave it there for a year, 365 times 1. Take my $1 out. What I get here is called the average rate of return. Now, if you look on your sheet, what's wrong with this formula? Yes, On your sheet, this is a minus and it should be a plus. Okay, this should be a plus on the sheet. It's not a big deal because it's actually not on the quiz, most likely, okay? If we do, it's never been on a quiz yet that I gave, so 1 plus 0.052 divided by 4 to the power of 4. This one is 0.053023. Sometimes you have to go out a few decimal places before these are different. That's why I put quite a few places. 1 plus, somebody be checking me, please. Make sure you're getting this. Okay. Divided by 365 to the 365. Take off the dollar. This one I have 0.052525, blah, blah, blah. This is compounded more often, but the rate is smaller. It was 5.2 and it went down to 5.12, okay? That's why you're not always sure. This is one, if I looked at that, I couldn't have told you which was going to be a better deal, right? I would have thought, well, this one's compounding a lot more often, but that one's a slightly higher interest rate. That's what this is for. It's comparing things that aren't apples to apples, okay? So now we figured out that actually which is a little bit better. This one has a little bit higher rate of return, right? Just a little bit higher. Do you see, though, if you'd rounded it here, how they would have had the same answer? So you want to keep places when you do that one. All right. Now we're going to get to the fun ones. I'm going to actually skip to number, well, all right, let's do 6 and then 8. 6, you have your first full-time job and you decide to start an annuity to save for retirement. You're going to put $50 a month. Where are we going to put that? Payment, 50, and you're doing it every month. So payments per year and compoundings per year will be 12. For the next 40 years, you're going to do this. So N is going to be 40 times 12. Somehow you're going to get 6.5% interest. Okay, we have 2 spots left. What are we trying to find? Future value. So what are we going to put in present value? 0. Yeah, don't start with $50 even in the account. Just put 0. Yeah, leave it at end of the month. Yeah. All right, so if we go up here, I already forgot what we're doing. 40 times 12. Well, I covered the problem up, so. What was the interest, guys? Thank you, 6.5. Present value, 0. Payment, 50. 12 and 12. Okay, so what does our future look like? If that's your retirement account in 40 years. Okay, yeah. It sounds like a lot of money, but it's probably not going to do us for retirement, right? All right. Guys. Okay. I want to jump down to number 8. Number 8 is going backwards. It says, you want to retire with $1 million. So where are we going to put that? Future value. Make sure you get 6 zeros in there when you type it in. You're willing to work and make investments for the next 50 years. So N is going to be 50 times 12. And payments and compoundings will stay 12. This time we're going to get 8% interest. Present value is still 0. What do we need to be socking away every month to become millionaires in 50 years? 50 times 12, 8% interest, and our future value, we want it to be $1 million. So our payment, you'd be surprised, N is 50 times 12. All we need to do is put away $126.08 a month. Okay, but guys, when Well, and when you leave money in, like if you put money into the, for example, the stock market, and you leave it there for 50 years, you're going to get a really good rate of return, okay? The average rate of return. Even like my stepdad's got money, and when he put money in the stock market, there's been years where he lost a lot of money. But over the course of the time he's left it in there, he's probably averaged like 18% because it's been in there for so long. All right. We're going to do a car problem because that's what you guys really care about, right? You're going to borrow $7,000. That is your present loan. Okay? You're going to pay it off over 5 years, so 5 times 12. The interest rate is 6.8%, which you can do better than that today. The payment is what you care about, right? What is the future value if you're, okay? And these are going to be 12 and 12. So if you went out today and you borrowed $7,000 and you had a really cruddy credit rating, so they were going to give you 6.8% interest, 5 years, so 5 times 12. Present value $7,000 I'm borrowing. Future value 0. What's your payment going to be? Anybody got it? Almost $138, right? 137 and how much? 95. Okay. This is a better question. Suppose you say, I can afford $250 payment. I'm going to borrow money for 3 years, so 3 times 12. They're going to charge me 5% interest. How much can I go shopping with for my car? Okay. Future value is still 0, 12 and 12. So this is where most of you think you should probably start, right? You should say to yourself, how much can I afford for a payment? And then work your way back to what you can afford to buy. What was the interest, guys? 5? Present value is what we want to find. The payment was $250. So how much can we go shopping with? Okay. 83, 41, 43. Okay. So if you were going out to shop for a car, you might want to look for one that's $7,500 or $8,000 because then there's fees and stuff, right? Because you're trying to keep your payment under $250. Okay? All right, guys. Your assignment again is to be working on page 171 and worksheet 5. Now there's some things on worksheet 5 that we're probably going to want to talk about, maybe even tomorrow, definitely Thursday, okay? But there are also some problems on worksheet 5 that are about finance and buying a house and annuity, so find those if you're confused, okay?